Okay, thank you. Welcome for coming. Why did this skip? There we go. So I'm here to talk about how we can harness this explosion of advanced microcontrollers that's coming at us, this wave of new intelligent systems, and what we need to do from a software perspective to enable that. I don't know how many people were at the keynote this morning. Raise your hands. Okay. So, I don't know how you feel, but I've been in the embedded software area for quite some time. I started off as a software engineer. And I always thought we could do much better with the embedded systems, make them easier to program, make them more versatile, more connected, more intelligent. And I was really excited to see Oracle moving in this direction. Judson's keynote, I think, this morning was very compelling, laid out a very compelling vision for addressing this huge opportunity together. So I'm very excited to be here, to be part of this. My name's Terrence Barr. I'm a senior technologist at Oracle, and I'm also the product manager of the product I will be discussing today, the Oracle Java ME embedded software. Initially, I'd like to go into just a little bit of an overview of what the opportunity is that's lying in front of us, and some of the challenges that are present when developing, these rich, intelligent, connected clients, and then, of course, what role Java can play in that. Go into a little bit of a deep dive of the Oracle Java Embedded client product. I know this is a business audience, so I'll keep it high level, but I think at any time, if you have questions, just interrupt me. We can go into more detail. And then I will talk about 3 use cases where using Java for these client devices creates, tangible business value for the customer and for the partner who's delivering the solution. And a brief wrap-up. Okay, so we heard a lot about M2M this morning in the keynote. M2M, of course, being machine to machine. So it's any sort of connectivity between 2 intelligent devices. They exchange data, create data, move data around, base decisions on that data. And come in. And traditionally, these M2M systems have been around for a long time, right? And traditionally, they were sort of single point dedicated solutions, right? The whole stack was vertically integrated. You started off by creating an embedded device, selecting the platform, selecting an operating system, selecting your tools, your libraries, selecting some protocols, integrating everything together, writing a dedicated back-end infrastructure to manage that solution. And basically what ends up happening is the solution works, but it's just a lot of effort. It's expensive to bring out into the market. The time to market is pretty lengthy. And it's just an approach that's not scalable in the long term. So what we see happening is that there's a pretty radical shift in the M2M space where we're going from this proprietary single function approach to a more horizontal platform-based and more integrated approach, right? Essentially, we're transitioning from proprietary solutions, from proprietary networks and standards to open standards and network protocols. And along with that, we need to enable a horizontal delivery service enablement platform, right? That takes care of things like security, upgrades, lifecycle monitoring, data management and analytics. Because it turns out that if you look at many of the M2M use cases in market, they all require sort of similar plumbing underneath. They all require a certain amount of horizontal functionality, and of course it makes sense to create that in a standards and platform-based way and then reuse that as you move from use case and market to the next opportunity, right? So that's really what's happening. This horizontal platform enables the spread of these vertical applications. So instead of reinventing the wheel every time, you base your solution on that horizontal platform. You build a vertical application to deliver that business requirement, that business solution, and your time to market is much, much quicker. And also, M2M is all about data, right? And not just data, it's information. So data that you haven't processed and analyzed is useless. You need to process, analyze, and filter it and turn it into information that is relevant for your business need, right? And so that's also where M2M comes in, because as the data flows from the edge of the network up back into your systems, you're going to filter and analyze it along the way to reduce the amount of traffic and to make the information more valuable, right? And so all of that is common functionality that every M2M design really needs. Now, if we look at the client, specifically microcontrollers, so really small, low-cost, resource-constrained devices, these are the ones that'll, be shipped in the billions and billions. As we heard today from ARM and Freescale, those are the sort of disposable computers of the future. But creating software for these today is just a very cumbersome business, right? So you have to integrate all these different parts and components. Makes it very complex. You need to choose your platform, your CPU, your operating system, your programming languages, your libraries. These are just some examples. And this just doesn't scale very well. So we need to move on beyond this model to really be able to harness this wave of microcontrollers and make it much more efficient and streamlined to create, business intelligence and algorithms on these devices. So to take a little step back, when you're building one of these embedded systems for your target use case, there are a couple of things that you really have to worry about. These haven't changed over the years. These have been true for many years. People building these embedded systems, you have to worry about how do you connect these devices. You have to worry about security, manageability. How do you track what these devices are doing? How do you monitor them, right? Cost is always an issue. How do you reduce the BOM cost, the cost of your solution? And then on the delivery side, time to market, right? As more and more vertical industries understand the value of these types of solutions, you need to start delivering more of these solutions quicker and more cost effectively, right? Developer productivity is a big part of that. If it takes you 9 months to create some software, your market window might have passed or your competitor might have stepped in, right? And as part of that, of course, also supporting standards, right? The more standards you can leverage, the quicker your time to market is, instead of reinventing what you need every time. So if we take a broad sort of view of what the embedded space is in terms of the actual hardware devices, right? We start at the very large, so at your right side. These are typical systems that are, not cost sensitive. They have a fair amount of compute power, typically large amounts of memory. So these obviously are not, the types of systems I'm targeting in my talk here. We go down a little bit. The devices become a bit more cost constrained. They're often used in sort of consumer electronics, right, like Blu-ray players or smart TVs. But you still have the need to be able to update them. There's still some cost sensitivity. We go down further into the small range. What is labeled here as general embedded. So this is really sort of the vast range, I believe, where the bulk of the numbers will come from. So these are the microcontrollers, the low-end resource-constrained systems, where you're very constrained in terms of cost and size and power, but there's a lot of compute ability. If you look at the Cortex M0, M4 type architectures, these are microcontrollers, costing only, 50 cents or $1 for an SoC, but they're pretty powerful platforms. You can actually utilize them in many interesting ways. So that's sort of the focus area for my talk. And then on the far left, there's Smart Card or Java Card, which is sort of a special case because it's more dedicated to the security of systems. So it typically integrates with other devices to provide a secure environment. But what you have across all these systems, or ideally would like to have, is a common set of functionality, right? So you have a set of APIs and libraries that you can use. You can create applications that work across of these platforms, and you have a level of hardware abstraction so you don't have to deal with the device dependencies of every single platform you're looking at. So if we drill down a little bit deeper into what does this mean for small embedded devices specifically, right? So as these devices become smarter over time, they need to acquire more intelligence and more functionality to be able to integrate with this M2M solution scenario that I outlined. So we need robust operation. These things have to run 24/7 for years at a time. They have to be managed remotely. So once you have devices sitting out there in the field and you need to push software updates to them, that has to be fully manageable, even out in the field under difficult conditions. They need to support various types of interfaces to connect to the world around them, be it sensors or networking capabilities. Low footprint is something we already spoke about. Economies of scale, so you need to be able to take your solution, as I said initially, take your solution and scale that to different use cases and different markets without having to rewrite everything you're doing and changing your model. You would like to be able to separate hardware and software from each other. Why is that important? In the embedded space, typically what happens is that you have to develop for a dedicated hardware platform. That hardware platform in your development cycle might not actually be available at that point when you start software development. That board might still be in design. The system on a chip might still be in design. So you are now pipelining or making sequential the development process where the software team has to wait for the hardware to be available, right? Which of course increases your time to market. What you want to be able to do is have the software and the hardware development happen in parallel, and they come together at the end. Intelligence is really important. As I said, one of the big benefits is that we can start delivering more intelligence into these devices, as Judson spoke about this morning as well. There are many types of data filtering, of data gathering, of local business intelligence that you can push to the devices to create more meaningful data quicker. And having smart embedded devices allows you to build on top, right, create value up on the stack rather than reinventing the wheel at the bottom. So that's essentially where Java comes in. That should be fairly obvious. But I think it's very important to abstract a little bit from the technology itself and understand that Java is this common platform that allows you to sort of push away all the complexity of the underlying client. It allows you to build a solution that's much more scalable and portable across your different markets and use cases. So don't reinvent the plumbing every time you start a new project. Build on something, and then you're only adding the last 10, 20% because the other 80% have been done and tested for you. But Java is actually much more than just a platform abstraction, because Java offers, Java essentially enables the device as a service platform. So this is a bit of an eye chart. Maybe I have too much information on here, but the core statement here is that by using Java, you get an application platform that allows you to continuously deliver and update services that translate into business value without impacting the integrity of your system. It's a very simple process. In the past, if you wanted to do that with native platforms, there was a lot of complexity involved, security issues, and it was just something that wasn't done very often. Whereas with Java, you can extend the lifetime of your solution. So let's say you have a smart meter use case, right? Every once in a while, standards change. Standards get updated. If you have a device out in the field that sits there for 10, 20 years and monitors energy use, you need to be able to update the algorithms by which it does that, right, if the standards change. And it's a non-starter for somebody to have to go out into 50 million homes and update the software somehow. What you want to be able to do is push down the logic out in the field in a secure, robust way. So that's really, it drives business value because you can make your solution more long-lived and more valuable to your customer. So to wrap up the first sort of high-level introduction, I think this slide, there was a similar slide on this morning where, this is an abstraction of how Java delivers business value in different ways. As I said, it extends the product lifecycle. It gives you a competitive advantage because you spend less time on building the plumbing and you can focus on your value add and your expertise. It drives innovation because there's a large pool of talented developers out there that are itching to write software for this, right? So you can innovate much quicker. And there's this large developer ecosystem. On the cost side, as I mentioned, because you have a much more portable system, it reduces cost, increases time to market, and you're building on a well-tested, reliable, secure platform that's been battle-tested over many years. In the case of our product, we've shipped this into millions and millions of phones over the last couple of years. And so you can rely on all that functionality to work. You spend much less time testing that whole stack, right? So to get a little more product specific, you might have seen this in the keynote on Sunday, in the technical keynote if you attended. So we released 2 new products in the embedded space last Tuesday. On the left, there's the microcontroller or the small embedded product stack called JavaMe Embedded. 3.2 is the current version. So that's the product I will be talking about in the rest of the presentation. And then we have the Java Embedded Suite 7, which is a pre-integrated full Java runtime database application server, which you can use typically for sort of the middle tier of M2M architectures. So that's, managing devices that are connected to it, collecting data, filtering and analyzing data, establishing a connection to your enterprise intelligence on the back end. That's what Java Embedded Suite will be used for. And the two, work ideally together on the 2 different tiers of an M2M architecture. So let me talk about the product. How are we doing for time? Okay. So, so the official name is a bit wordy. Oracle Java ME Embedded. So as I mentioned, we took all the expertise, all the technology that we had for the mobile phone space, and we optimized that and customized it for the needs of embedded platforms. So this Java runtime is a complete Java runtime. It's essentially ready to use. It has all the components that you need and it's enabled for low footprint, resource-constrained ARM architectures. So what we did is we're targeting, and I'll talk about the system requirements a bit, we're targeting a very broad range of horizontal type of platforms with this product. It's optimized for embedded in a number of ways. It has very robust 24/7 operation. We have a number of extensions in the product that make it more portable, that make it remotely manageable and monitorable, and another number of other features that are relevant for this type of use case. And we have a number of new APIs that we introduced into the product that specifically allow applications running on this platform to trigger various types of embedded functionality, so interfacing with devices, for example. By using the existing Java platform that we had for the mobile space, we are also bringing over a number of standard JSRs, so Java specification requests. Those are the API standards in the Java world. So these are all existing JSRs that people have been using for a number of years, people are very familiar with, and it gives you a rich set of functionality to build upon. Right, we'll go into a little bit more detail on a product chart. And then finally, we support this platform with a tool chain, multiple parts of multiple tool components, because of course, making it easy for developers making developers productive has always been a big part of the Java platform, so we support this product directly with the standard tools that Java developers are very familiar with. So in this release, release 3.2, which is our first release targeted to the embedded space, these are the types of platforms, the types of hardware we support. The main target for this release is really wireless modules and horizontal M2M, so a general platform. We expect that partners will take this product and then customize and specialize it for particular use cases in their area where they have the expertise. But the goal of this product is to be broadly applicable and close to deployment. So it should not take a lot of effort on the behalf of the partner to create an optimized deployable solution. So as I mentioned, we are supporting ARM architecture system on a chips, and that includes ARM9 implementations, ARM11, Cortex-M, R, and A. So that's a pretty broad spectrum, pretty much from the small microcontrollers all the way to embedded type server environments. The dash A, Cortex-A would fit that. So very scalable product down from about 130 kilobytes of RAM on the low end. If you customize it and you're really pressed for space, you can make it that small. But it runs really well starting at about 700 kilobytes of RAM and can scale up to megabytes of RAM easily. So it's very versatile. The type of device is a headless device, so we're initially targeting sort of the deeply embedded. You don't have an HMI, you don't have a user interface, so everything's headless, resource constrained, as I said, and always on devices, including battery operated devices. The operating system, we are pretty flexible. All you need is a small embedded kernel. Doesn't have to be able to do much. And the platform is very portable, so if you have particular, check marks on requirements for an operating system, we can probably support that easily, or the product can support that easily. I get questions and people say, do you need Linux? No, Linux is way too big for this space. I mean, we're talking about less than a megabyte of memory, so Linux is not appropriate. In terms of networking and connectivity, that's always very important in this space. So we support a variety of different connectivity options. There's a full IP stack in there, as well as a range of peripheral I/O. Our partners, for example, Centurion is using this product. They, of course, have this product on their wireless modules, so it's 2 and 3G connectivity. What's also very important is that you give the system the ability to intelligently use multiple communication channels if available. So a typical use case in the, for example, in the smart metering use cases, these systems might be sitting out in the field for long times, monitoring gas and water and electricity use. And typically the connectivity out in the field might not be very good. You might have limited data bandwidth. The prices might vary dramatically, time of day, different carriers, providers. So what's standard in the industry in that type of use case is actually to have 2 SIM cards on the module. Sorry. You actually have 2 SIM cards on the module, and depending on your particular needs and the logic of your application, you want the system to be able to switch intelligently between these 2 communication channels based on some policy, right? So for example, if one channel goes down, you switch to the other channel, that's more expensive, but it's a backup channel that works, and then you start reducing your data bandwidth, your data needs, right, until the other channel becomes available and you switch back. So that's an example of local intelligence where you can provide a better solution by having local software and local algorithms running on the system. Okay, in terms of peripheral I/O, we have all the basics in place to connect to various bits of hardware. So things like sensors, actuators, meters, buttons, contacts, all these things you can support directly from Java, so your Java application can directly access those. We also support file systems and GPS, location-based services, if the hardware supports them. So all that functionality is there. So let's dive a little bit deeper into the software stack. This is actually simplified. The full platform has more components than this, but these are the more important ones. So we start at the lower part, at the embedded hardware and RTOS. We're really agnostic to that. As long as it's an ARM architecture with a reasonable operating system, the product can support it. We have a porting layer that comes from many years of experience of working with mobile handset manufacturers and having the ability to port quickly to a number of different platforms. So that's in there. That would be done either by Oracle Engineering Services or done by a partner if they have the expertise in this. So if you have some platform that you need to support for your particular use case, that would be the place to do the porting and the adaptation. In terms of the runtime, so the next level, it's the CLDC High Virtual Machine. So that's Oracle's implementation of the Java ME standard. Very robust virtual machine, including multitasking, so you can actually run multiple applications in parallel. So it offers a really rich set of functionality, including also on-device debugging. So if you have your application running on the device, you can actually very, very nicely debug it in your integrated development environment. On top of that, the application model is IMPNG. I don't know if many people are familiar with that. It's kind of like mid-P in the mobile space, but without the graphics. So that gives your applications the context in which to run and a number of APIs and features. And then all the little boxes on top are different types of APIs, different types of functionality that you can use. I don't want to go into every one of them, but you can see that it's a very rich platform, even though we can run comfortably in less than 1 megabyte of memory. You actually have a number of features available to your application. So you can actually create very sophisticated, intelligent, connected applications that can do a number of things. For example, they can process XML streams. They can support certain protocols that the backend might need. They can control the whole system and the way applications run to implement your own remote management functionality. So there's a lot of functionality there. And then finally on the right we have the tools support, as I mentioned. So we have, actually I'll talk about the tools in a bit. Okay. So I don't know how many people in the audience come from a native embedded background, developing native applications. I mean, all the benefits of Java that I described earlier apply, but I wanted to dive in a little bit deeper just to give you a bit of a sense of, on a technical level, where Java competes with, for example, C and C++ and assembly development. Now, of course, at a portability cross-platform level, there's no contest. Native code ports very difficult. Involves changing your tool set, recompiling, retesting. Java just works, right? Because it's in a sandbox virtual environment. Security is tricky on native. You have to do a lot of testing, and you can't always rely on the underlying platform being robust and secure. Whereas in Java, that's proven many years that there's a very robust security model, including permissions and signing and things like that. That also extends, of course, to the robustness of the system, because you're running on a underlying platform that's been battle tested over many years. Chances are your solution is going to be very robust. That's something that's hard to do on native unless you spend a lot of time on testing. With the advent of multi-core, right, many system on a chip designs today will have multi-core going forward. So the ability to run multiple applications on different hardware components to speed up and do more sophisticated algorithms. That's tricky to do in native, typically very system specific. In Java, that was built in from the beginning, so you can support multiple cores and multitasking very easily in Java. Again, with a portable design, so you can move that to a different system which might have a completely different architecture and different types of cores, different features, and it'll just work. Performance, that's something people always worry about. You know, Java is really slow, right? Those were the old days. What we're seeing is that Java is very well suited for many, many applications in terms of performance. And in fact, native is not always as fast as one might believe. It depends on the circumstances. I spoke about updatability. Again, that's very good in Java because you're not actually shipping around native applications. You're shipping around Java applications which are just modules that get downloaded and installed and run in a sandbox. They don't affect the integrity of the system, the stability of the system, and that's very hard to do in native. Of course, the development model is something that speaks for Java, so you can use the same skills and the same tools going from large server enterprise systems all the way down to embedded. That's much harder in native, where typically you switch from one platform to the other and you have to start over. It's much harder to get embedded expertise, development expertise, whereas there's a large pool of 9 million developers in Java. Now, granted, they're not all embedded Java developers, but the step to become an embedded Java developer and understand the limitations of the system and the design challenges in Java is, of course, a much smaller step than in native. I don't want to spend too much time on tools, but just suffice to say, we have a complete range of tools that allow you to develop embedded Java applications very efficiently. For a typical software developer in the embedded world, this is a godsend. They are used to a much more difficult development environment and development process. Here you just use high-level integrated development environments and you write Java code just like you would on any other Java-based system. There are, of course, certain limitations. You know, there's only so much memory you have, but fundamentally your expertise applies here as well. So we're going through this fairly quickly. If you have any questions, let me know. So now you have a background on the product, on the types of environments we're targeting. I wanted to speak about 3 use cases that I found very valuable to highlight sort of the business advantages of using Java on the client. The first one is probably one that you've heard already at the conference, our partner Centurion. But I still wanted to highlight it because it's really almost an ideal use case for what we're trying to do here. And so Centurion has been a long-time partner with Oracle in the Java space. And their modules are really, you know, these small wireless modules completely integrated, including I/O, connectivity, and everything. They're complete computers without a screen. Run off a battery, low power, low cost, and they are being used in a wide range of use cases across different industries. So industrial automation is one, healthcare, I'll talk about that in a second, security, monitoring. So it's really Centurion's way of adding intelligence to these devices. And in fact, one of the major reasons that Centurion went with Java, and that's, you know, all the other benefits aside, you know, big developer community, productive environment, it was actually because they wanted to get away from native code as much as possible. Native code impacts their system design. Every time you change native code on these wireless modules, you have to requalify the module, right, because it has a radio stack, so you have to go through recertification of the local authorities. They wanted to get away from that and make the native layer as slim as possible and never ever change that again, and add all the business intelligence, the application, the management of the module, go to Java, because that's just a much easier way to provide that software stack. So they're smart programmable devices, as I said. They are running Oracle Java Me embedded client, so they're running this product. And Centurion specialized this product in a number of ways. They added remote management and provisioning functionality. And they are helping their partners to integrate with the particular solution, right? So that's Centurion's value add here in creating that customization for a particular industry. Yes?
What is the operating system on this? That is one.
You know, I don't know, and you don't care. You never see the operating system.
No, I just want to.
But,
the reason
yeah.
I'm asking is if we were to use this new embedded, Java only embedded, so typically use case, so what is the operating system there?
So you mean of the Centurion solution?
Yes, yes.
Okay.
In this use case.
I don't know what the operating system is, and Centurion, I believe, is flexible to change that based on the requirements of the customer. But the whole point is that as an application developer, you never see the operating system, right? You just see the Java layer. You turn on the thing, it boots up, and you run your Java application, and you're completely abstracted from that. That's, you know, Centurion does all that integration work for you. But, you know, typically in this space, there are any number of small real-time kernels. You know, ARM has their own. It's called RTX. There's, you know, ECOS is an open source version. There's ThreadX. There are a number, you know, number of operating systems, and they all are, you know, fairly similar. They have a certain type of functionality, and the Java stack just plugs into that, and off you go.
Let me ask. The reason I'm asking is this product, this is a new product. In most of use cases, do you already have this IT stack within the operating system?
You mean the networking stack?
Yeah, the IT stack.
Yeah, typically you would rely on the operating system provide. So what you need from the operating system for this product, for the Java runtime, you need a simple way to execute a thread, which will be the Java, you know, virtual machine. You need some basic memory management, although most of the memory management is done by the Java runtime. And you need a set of drivers that support that particular platform. And once you have that, you just build the Java runtime on top. So it's a very, very smooth integration path, and any software that you wrote on top in Java just seamlessly migrates from one platform to the next, right? So here's a case study that that Centurion and Oracle have been talking about since last year. This is a device by the Philips Healthcare division. It's called Philips Respironics System 1. And it's a really interesting device because it's something that showcases how you can make patient healthcare much more efficient with the use of these small embedded devices. So what this device does is it actually monitors the sleeping pattern, the breathing pattern of a patient at night when they're sleeping, you know, to monitor sleep apnea and things like that. And the system continuously monitors the pressure that the patient has, the volume of the air intake and things like that, the frequency. And it collects that data, it does some pre-processing on the data, and then sends it to the healthcare provider. So the doctor can actually sit at the terminal in the office and look at all the data that's accumulated over some time and can detect, you know, problems in the patient's breathing pattern. And in fact, the doctor can actually make changes. So if they see, you know, for example, there's not enough pressure applied when the patient is inhaling, then the doctor can actually change that parameter. It's getting pushed down to the device. And so the doctor can actually adjust the care that's being provided without the patient ever having to come to the doctor's office, right? So it's a very compelling system that allows you to provide better care while reducing cost at the same time.
And in this case, the functionality you described is actually in Java running on the...
Exactly. So all the local functionality, all the intelligence, the connectivity to the actual device, everything's running in Java. Java does the pre-processing of the data to make it more valuable, connects to a backend, and then also receives the parameters that are being pushed down, turns around, and affects the behavior of the device. Right. And so I found it really interesting to give you a quote from the Senior Vice President of Centurion's, Gemalto's Centurion unit. because it wraps up pretty nicely, I think, the value that applies to Java in general in this space, right? So it's an open, robust, cross-industry application environment that makes development and deployment of software services and the integration with backend services much more efficient. And it ultimately improves the bottom line because you deliver a better product at a lower price and you're quicker to market and you're more flexible. Moving on to a slightly different use case. This is one that is currently being rolled out in a trial environment in Germany. Deutsche Telekom AG, so one of the largest carriers, has worked together with Quivicon and Processed to deliver a home automation platform into the European market. Now, admittedly, this platform, you see the yellow box in the middle, is actually a slightly larger platform than the Oracle Java ME embedded product because it runs OSGI as a framework. So this is a more capable platform in terms of hardware and processing power. But the concepts, this was devised before we launched this product, but the concepts apply just as well. You could do a lot of this with a smaller device now, a microcontroller-based device. So what this system does is it's basically a home automation gateway that sits in the home. It's connected via DSL. It can interact with all sorts of peripheral I/O. So, for example, Zigbee devices, which is short-range wireless communication to turn on and off lights. It can interact with your home ventilation and heating system. It can do it has a number of integration points with different components in your house, including other consumer electronics devices. The really interesting aspect of this is that it's completely managed by the carrier infrastructure. So you can actually push new applications down to the system. There's actually, or will be, an application store. So they envision that third-party service providers can actually write applications that add functionality to the system, offer it in a store, and the user can then actually select their application and change the behavior of their system that way. So it's a whole integrated solution, including software, hardware, management. That's being rolled out in Germany at this time. It's in field trial, and they want to go live, I believe, next year. And so if you look at the business analysis behind this, there are a number of benefits that the Java platform brings to the system. Time to market was a very critical one. They could have not done this by developing their own plumbing on both sides, right? So they use Java on the back end, Java on the client. So time to market, very important. Of course, over time, they will start offering different client devices, different home automation gateways for different user types, user requirements, different integration. So they have to be able to change the hardware over time without reinventing the whole client software, right? So the ability to swap out the hardware and put in something else underneath was an absolute requirement. You need to be able to manage these devices remotely because they're long-lived. Things might go wrong. You might have to push new software on them, new security updates, new integration features. So remote management and updatability is key. Local intelligence. So by having the ability to execute algorithms locally, you can involve third parties and they can build applications that customize the functionality of the device depending on the user needs. So all these things is what the Java platform brings to bear. And I think if you talk to partners like Process, they will tell you, they've been involved in this for many, many years and they see Java as the key component to all of this. Another use case, the third one I want to talk about is sort of the concept of smart grid in general. So we heard Freescale this morning talk about the need to make our electric grid more efficient, more adaptive. Oracle has been working with partners in various markets for a number of years now. There's a big deployment in France, for example, with EDF, Électricité de France, because of the mandate of installing smart meters across the country. So we have an architecture that supports that. But I would really like to go into the client aspect on the right, and specifically the application, smart metering and adaptive energy use cases. So smart metering is the ability, of course, to monitor energy use and optimize energy consumption with the help of an adaptive energy use system, right? So there's this concept of demand response, energy demand response standards that are being developed, where the utility can essentially set a price and react to demand and supply imbalances in the grid, right? So for example, on a hot summer day, everybody's turning on their air conditioning. The utility will want to basically send an event to all the consumers saying, okay, we're at the limit, I'm raising prices, please try to reduce energy use if it's not absolutely critical, right, to your operation or to your home, to your life. So to make the grid much more efficient and balance supply and demand. So that's what adaptive energy use is about. And we actually have a demo on the demo grounds at Java 1 showing off an energy demand response client, which periodically polls this energy demand server on the internet, waits for energy events, and then can react to the event based on the parameters that the user sets. So the user could, for example, say, all right, I can afford to turn off this row of lights, right? Or I can afford to raise the temperature of my AC control, by 2 degrees to conserve energy and reduce my cost. So the benefits of Java here is, again, very important, the ability to swap out the hardware over time. These systems are deployed over many years. Électricité de France in France, that was one of the key requirements. We need to be able to multi-source from different hardware vendors, these smart meters, and we can't afford to rewrite the software every time. You can update the software in the field, of course. So for example, if you want to add new functionality, support new standards, you can do that even if the devices are sitting out in the home somewhere far away from your central management server. Also here, the ability to add local intelligence is very important. We heard this morning about this deluge of data that's coming, like all these devices producing petabytes of data. And it's absolutely mandatory that we find a way to reduce the data at the source and extract only the valuable information and send that back, rather than a lot of noise with a little bit of information, right? So for example, in the case of smart grid, what you want to do is you want to filter your local data. You get lots of energy usage measuring points, and you want to filter that data and find out where the interesting changes in energy consumption, right? And only send those back. Or maybe even coalesce them and only send packets every once in a while, because you don't need an immediate response. It's good enough to do it once an hour, right? So reducing your actual service cost, because of course every time you send a packet over a cellular network, it's going to cost you money, right? So the less data you send, the more valuable the data is, you reduce your cost immediately, right? You need to support, obviously, a variety of protocols and interfaces, both on the local connectivity side. What devices do you interact with? Different types of meters, for example, different types of interfaces to control your consumers, but also upstack. You need to talk to different types of integration points on the back end that might implement different standards, in different countries, for example, energy standards. Yeah, so that's what I wanted to talk about in this use case. So that's pretty much at a high level what I wanted to talk about. Just give you a little bit of deep dive into the roadmap and what you can expect over the next 12, 24, 36 months. Again, apologize for the eye chart. I think what we'll focus on is the lower part, the gray area. So We're in 2012 now. We've released these two, the JavaMe Embedded 3.2 product, as well as the appropriate corresponding tool set, JavaMe SDK 3.2. We are currently planning to rev this product very quickly because we're already seeing a number of people coming to us and say we have additional requirements. Can you fulfill those? So we're planning a update release first half of next year, roughly, with a couple of features to enhance integration points, support more platforms out of the box. And then really the big incremental step will be in the summer of next year time frame, late next year time frame, where we upgrade to the next version of Java ME. So we just filed 2 new Java specification requests yesterday, the day before yesterday, essentially to bring the small embedded platform up to the standards of Java SE, so you can use a lot of the language features and API features of SE, which makes the platform even more homogeneous and allows developers to translate their skills even easier. So there will be a number of new features coming in JavaMe Embedded 8. And then the tools will support whatever we do as well in parallel. NetBeans IDE always has the support for the latest and greatest features of these products and platforms. So a pretty aggressive roadmap, a number of products that need to be coordinated. You know, in parallel, we also have Java SE embedded for the larger systems, evolving over time. We're also bringing together some of the functionality to align big Java and small Java, again, to make the platform easier to address and more homogeneous for developers and people who are deploying this. Yes?
Java SE timeframe 2014. There was some discussion about the scalable architecture, right? Now, that means these two will go in parallel. That means Java SE 8 and Java Me Embedded 8. These two will be 2 separate products.
Yes, right. So Java SE embedded will have more tunability, more modularity over time to be able to address a wider range of systems. But pretty much because Java SE embedded was designed for large systems, there's a lower bounds on how low you can take those systems. Right now it's around maybe 16, 24 megabytes roughly. So with Java SE embedded, you can't really address the microcontroller market. You never will be, and it's not designed to do that. So that's where Java ME embedded comes in. So ME basically can span from the lower part up to where it meets SE system requirements. So we'll basically have 2 products spanning the entire range. Currently we have 3. We also have the CDC product, but that's going to be integrated in Java SE embedded going forward. So again, the story at the end of the day is it'll be one Java aligned in terms of features, languages, tools, and then you just basically pick and choose which product you need to run based on your hardware requirements. So it's going to be a very simple choice, and again, you know, reduce complexity, reduce time to market. That's the goal.
So because today, if you look at Java micro edition, so we have CDC and CDC.
Right.
So moving forward by 2014, CDC will move into...
Exactly. CDC is covering sort of this middle tier, but we're making Java SE embedded more configurable, more modular, so that it can cover CDC. And the CDC product basically goes away. So it makes things easier. But we'll still cover that range of devices. Yes?
I have a couple of questions.
Sure.
First, my extend his question, is the plan to have then Java MESE9 configurable, to have one software package where I can extract some components and use it then in small footprints and bigger footprints? This is the plan?
So the plan is, will there basically be one product that's completely tunable? And the answer is no. And well, that at least not in the near future. And the reason is that fundamentally the design of the software, of the runtime, has to be very different depending on your target. And it's essentially not possible to develop a Java runtime that scales from 1 megabyte up to 500 megabytes. It's just software architecture, just it doesn't work. So we'll probably, for the near future, have two products, one that scales, from 0 to 10 megabytes, 20 megabytes, and the next one that scales all the rest. That's the plan. But from a developer perspective, because we're aligning at the developer level, at the API level, and the feature level, we're aligning the two. So as a developer, you don't care. You just know, oh, it's Java ME8 or Java SE8, but it basically has the same features. It's to the platform implementer, they have to make a choice. But the software translates just fine.
Okay. I continue with the next question. Talking with developers, give me the input that beside of the advantages of Java language and the structures of the language, they simply express some complexity, even in that environment. So you need to have an operating system. I personally have today not fully understood what is the real consequence. But when I think about, I have different microcontrollers with the ARM architecture, adapted with the different input-output interfaces, whatever it is. Then you need an OS which is finally impacting to the runtime. You have to adapt this. On the other hand, we learn things about data. The data have to be sent to any other machines, and you need protocols. How does this fit finally together that it is easy? So my developers just look for an easy system, using Java as wonderful language, but having a different operating system means complexity, and I do not agree with some of these contents. Updates are currently available all over the world in any router I have at home. So Telecom just sends me an update automatically into the system if I enable this. So this is not a real advantage. So what is the key argument using this structure when I compare this to other standard microcontrollers, choosing the standard operating system and giving this to a developer? What is then the key argument to choose Java embedded?
So compared to native development where you build your own stack, you integrate all the parts, you have an operating system. Right.
It's
okay.
Delivered with an operating system.
Right.
I just want to understand the benefits. Where can I reduce risk in development?
Right.
So beside of the Java language, this is outstanding. But when I see the system, then I see operating system, I see runtime.
Right. Okay. I think I understand the question. Yeah.
I see connections.
Right.
And when I see TCP/IP stack, then TCP/IP is a set of features.
Right. So yeah, so we only have 2 minutes left, and there was one more question back there. So maybe we can take offline, some of the details. But fundamentally, if you have a dedicated solution, somebody ships you a stack, you're happy with that. You don't need to make changes. You always stay on that platform. You just want to write your software for that dedicated point solution. Native is probably fine. That's what people have been doing for decades, right? Once you have the use case that you want to translate what you've been doing into different areas of your business, you want to support different types of protocols, different use cases, different platforms. You want to leverage some of the APIs and the features that the Java community has out there, right? Once you want to do a modular upgrade out in the field rather than reflashing the entire device, you want to do modular upgrades to save bandwidth and complexity. In all these cases, Java is, as far as I believe, a much better solution. It allows you to scale quicker. It involves less risk. It reduces your time to market. But we can take it offline, and I'd like to take another. There's one more question up there. Yes.
I'm a little bit surprised to see you advertising Java any Cortex class devices. Can you talk a little bit about how Java any scale going from ARM 9 to Cortex A9?
Right.
What things do you get? What things are better in Java, and you're running on a Cortex-A9 versus on?
What is well, nothing really changes from a developer's perspective. The system is faster. It has more memory. It might have more I/O bandwidth, I/O connectivity, but it depends. You would, from a system design perspective, you would say, okay, what are my requirements in terms of, you know, the ability to handle data, the ability to process data, to store data. What is my response time, right? And then you go choose the platform that meets your needs. Right, you can go very low if your requirements are pretty low. You go very low into the Cortex M3, M4, and very low system cost, a couple of dollars per system. Or you go into the A9 range, which is a pretty high-powered system if you can afford the space, the footprint, the power, right? But from an application developer perspective, and that's the beauty, nothing really changes. Your applications run faster. You can allocate more memory, right? You can do things quicker. You might be running multiple applications at the same time without degradation. But that's the beauty. If you develop, let's say you develop a horizontal application, a vertical application for some market, and that particular use case is very resource constrained. They have to watch the BOM cost, right? You will choose the appropriate system, Cortex A4, for example, low cost. Later, you go to a different customer. They have the same basic functional requirements, but they need more horsepower. You choose an A5 and A9, you can just take your software, drop it over onto that system, and you're done, right? So time to market dramatically reduced, development cost dramatically reduced. Because all you're doing is changing the underlying platform, and on top you don't notice what's happening, right? So that's the benefit. So we're done. Thanks for a good question, being engaged. I hope you enjoy the rest of the show. Thank you.